Hello everyone. Today we will discuss stateful applications, how Kubernetes handle that, and what we need to do. So first of all, before we proceed, what is a stateful application? Consider a scenario wherein you have your application deployed in production, and there are clients accessing that. Your application might be getting access via a REST endpoint or via any other mechanism. So if your application is uh, deployed on a node, if that node crashes, and your application will also be crash along with that. So if your application is deployed behind a load balancer on multiple nodes, and if one node has crashed, then does it impact the clients who were making the request, whose request were getting routed to that node via load balancer? If it doesn't make any difference, that request, one particular client request can go to node 1 first time, and then next time it can go to node 2, and next time it can go to node 3. If that's the scenario, then you are not managing the state. And if no node crashes, another node can come up immediately without worrying about any state management. But if the node 1 is maintaining some state, let's say client is talking to the application via load balancer, and assuming that there's a sticky session involved, and you don't need to worry about sticky session much. Basically, sticky session is if a particular client is invoking your application, and your application is deployed on multiple nodes behind a load balancer, then if the first time when the client invokes your application, it goes to node 1, the subsequent request from the same client will always go to node 1. So, and the reason you want to do that is because there is a sort of conversation between client and node 1. The node 1 is maintaining some state for client 1. So, and basically the state often means that you are maintaining some state in your class. There are some class level variables or things like this. So if you have such application which maintains a state, then, and you want Kubernetes to handle it, then you should use StatefulSets. So as I mentioned, in stateful application, each instance maintains a state. Each instance means you have 3 replicas of your application deployed, and each replica is maintaining a state. Now each instance has its own identity. Now what this identity consists of, and why do we need identity? First of all, this identity consists of the name, for example, host name, the network ID, and the state. State is obvious because each instance is maintaining its own state. Now, why do we need all 3? We'll discuss in the next slide. Actually, it's in the next line itself. When an instance goes down, the new instance replacing it needs to have same value for 3 properties. So if your application has 3 replicas, and node 1 node and replicas, port 1 is on node 1, port 2 is on node 2, port 3 is on node 3. Just an example. It's not necessary that each port is on different node, but for our discussion, let's say this is how it is. Now when the port 1 goes down, then there will be a new port which will be replacing this crashed port. Now this new port needs to have the same state of the port which got crashed, same host name, and the same network ID. If it doesn't do that, if it doesn't have the same value for these 3, it will not be able to get the same. It will not be able. It is not stateful set. We'll see in subsequent slide why is it so. But in reality, if it maintains the same state but host name is different, then it causes problem. It needs to have all 3 value same as the crashed port. Now, what is stable network ID? Each of this replica of this stateful set needs to have a stable network ID. So this network ID is stateful port is assigned an index. This index is used to derive port name and the host name, and also the stable storage to the port. Now with this index, the port's name become predictable because the port's name consists of stateful set name and the index. For example, let's say you have stateful set X, so and 3 replica. So it will have a port 1 with X name because that's your stateful set name, and -0 for the first replica. For the second replica, -1. For the third replica, -2. It is different than the replica set. So I am just using the the name replica, but in reality this is the one instance of the stateful set. So in replica set there is no index. It is some some the port and then the name of the replica set and then some characters, and there is no deterministic way of knowing what this value will be as such. Because this is different, and this is different. There is something called governing service. Now, why do we need this and what this is? So we have heard about service object, right? So something similar. When an instance of stateful set crashes, then we want to operate on a specific stateful pod from the group. So group is our stateful set, and on one particular pod we want to act upon it. Now, because we want to act upon each of the stateful pod of the stateful set, we would want each pod to be addressable by host name, so that we can reach out to that specific pod. So that's where governing headless service comes in. It provides network identity to each pod and assign DNS entry to each pod. Other clients in the cluster can address it by name. For example, let's say our governing service belongs to default namespace. We have discussed namespace in one of the previous video. If you don't know namespace, I recommend you go and watch that video. And our service governing service is called ABC, and one of the port is X-0. X is a stateful set name. So the port's fully qualified domain name will be X-0, which is the port name. ABC is the governing service name. Default is the namespace, and svc.cluster.local. This happens only with stateful sets and not with the replica set. So basically, you can address first instance of your stateful pad, stateful set with this host name. Second instance with X-1 and things like this. So this is what governing service does. Now, what happens when a pod is lost? So you have stateful set X. Pod 0 was running on node 1, pod 1 was running on node 2. You see X is the name of the stateful set, and 0 and 1 are indexes. Now this pod got crashed. So the Kubernetes will bring that same pod, maybe on the same node, maybe on different node. It doesn't matter. It could be if it could be on node 2 also. It could be an entirely different node. So when a stateful pod is removed, for some of these reasons. Node of the pod crashed. This node has completely gone. Pod is evicted from the node for whatever reason. Someone deleted the pod manually by mistake or deliberately because that person wants to start a new instance of the same pod for whatever reason. Then the new pod is created and the removed pod is replaced by it. The new pod has below properties same as a disappearing pod: the name and the host name. Now, when you are scaling up and down a stateful set, so when you can always today you have 3 instances of a stateful set. You want 4 or 5, and eventually from 5 you want to bring it down to 3. So in the your business might demand such scaling up or scaling down for stateful set also. So if you are increasing the pod distance, then the next pod will get the next instances. For example, if you have 2 pods in the stateful set which will use 0 and 1 index, the third pod will use index 2. When you're removing, when you're down scaling your stateful set, the downscaling happens 1 pod at a time, and we will see in the subsequent slide the latest pod will get removed first. If there are 3 instances, 0, 1, 2, the 2 one will go first, and 0 and 1 will stay if you are change your downscaling from 3 to 2. Now we all discuss the network ID, the name of the pod, but where does the pod maintain the state? If pod maintains the state in the memory, then whether the pod crashes or node crashes and pod goes along with that, then the memory is gone, the data will be lost. For that reason, the state needs to be managed in some persistent storage. And we discussed, some persistence volume, persistence volume and persistent volume claim in some previous slides. So it will use those things. So a new instance of stateful set which has come up because previous instance disappeared must have the same storage attached. Because previous instance was maintaining the state in a storage. Now if you attach the same storage to the new instance, so it not only will have the same name, network ID, but it will also have the same state as well. So in that, after that, it will become as good as similar as the old pod which crashed. So which means that the storage needs to be decoupled from the pods, which means when pod crashes, the storage lifecycle and pod's lifecycle needs to be different. You don't want storage to go when pod crashes, and vice versa. Vice versa is debatable, but at least you don't want to delete the pod when delete the storage when pod crashes. And also storage needs to be persistent. It cannot be transient, or it can be in the memory or something. It needs to be persistent. So each pod of stateful set needs to reference different persistence loop claim. So if you have 3 instances of your stateful set, then there will be 3 persistence volume claim. Okay, so each pod of the stateful set needs to reference distance persistence volume claim different than the other pods in the stateful set, so that each claim is different and it needs to have its own persistence volume. These claims are created by stateful sets themselves. We don't need to create the claim ourselves. If you are not using stateful set, then you need to create the claim yourself. We had seen in the previous videos. So at very high level, how does stateful set work? So a port template. When you're defining the stateful set, you define the stateful, give the stateful set information, you give the port template, and we'll see YAML of that in the next session. And you give the volume claim template. Then these are the ports which are getting created with 0, 1, and 2 indexes. The persistence volume claim also will be there, and each persistence volume claim will be tied to persistence volume. When you're scaling down, then only pod is deleted. Persistence view claim attached above a deleted pod is not deleted. So if when pod is gone, the persistence view claim is not gone. Why? When you delete the persistence claim, then the persistence volume, this claim was bound to PVC. Persistence volume claim is bound to some persistence volume. That persistence volume also gets recycled and contents are lost. So we don't want to lose the content. That was the whole reason of stateful set. So that's the reason persistence view claim is not deleted. And when the new pod which is replacing the old pod comes up, this persistence view claim get attached to the new pod. If you don't want PVC anymore, let's say you're deleting the pod and you know that you will never read the state of that pod at all, then pod is gone. Now you have to delete the persistence volume claim. You should go and delete that manually. When you're scaling up, at that time both pod and PVC are created. When you scale it down, PVC is not gone, but during scaling up, PVC is created. So if you want to know more about PV and PVC, check the previous the videos on the Kubernetes volume in the same channel. So let's say now when reattaching the persistence volume claim to new instance of same pod. So we'll run through this one scenario. So assume a stateful set has replica equal to 2 initially. It will be 2 pods. Each of the 2 pods will have corresponding claims attached to volumes. Now a change is made such that replica has become 1. So one pod is deleted with 0 and 1. The pod with index 1 is deleted. but its associated claim and the volumes are not deleted. Now when you are scaling it up again to 2, then the detached, pardon my spelling, detached claim and the volume will be reattached to the new pod being created. So that will happen. So now the new pod will have the same status as a pod which crashed. So we'll pause here. We'll stop here for this session. In the next session, we'll create a stateful application, and we'll create a stateful set in Kubernetes. This stateful application will be Spring Boot. Stateful set, application will be in Kubernetes. Stateful set, object will be in the Kubernetes. So we'll be creating some service also. Then we'll be creating some stateful set also, and we'll be testing our stateful application. So we'll have some commands to test it also. So that we'll do in the next session. Thanks for watching. If there's any question or any feedback, please feel free to write that in the comment. Thank you.